mathematics, we're going to be looking at word problems on completing the square. So if you see that question right before you, that you should solve 2x squared equals to 3x plus 5 using completing the square. Alright, so remember when we were deriving the quadratic formula via completing the squares, we used a series of very interesting steps. Alright, so we are going to be following those same steps as if this was ax squared plus bx plus c is equal to 0. So the first thing we're going to do is arrange this equation in the form ax squared plus bx plus c equals to 0. So let's do that. By that arrangement, watch my previous video on completing the square. Alright, so this is 2x squared minus 5 equals to 0. Alright, so we've actually arranged it in that form. If you x squared plus bx plus c. Alright, so there should be no confusion here because we are seeing plus bx plus c, but here we are seeing minus 3x minus 5. Alright, so the sign would be complemented for as we continue to solve this. Alright, so the first step was that we divide all through by the coefficient of x squared, so that the coefficient of x squared will be unity, that's 1. Alright, so the coefficient of x squared is 2, so I'm going to divide all through by 2, minus 3x by 2, minus 5 by 2, and I'll divide 0 by 2. Alright, so this would become x squared minus 3x all over 2 minus 5 all over 2. Of course, 0 over 2 is 0. Alright, so the next step we are going to take here is that the terms with x, you can see that the coefficient of x squared is 1, that is unity. Now, the terms with x would be on the left hand side, and the terms without x, that's a constant, would be on the right hand side. The only term that is without x is minus 5 over 2. So we're going to take it to the right hand side. And of course, when we take minus 5 over, the sign is going to change to plus 5 over 2. So this becomes x squared minus 3x all over 2 equals to 0 plus 5 all over 2. 0 plus 5 over 2. Of course, 0 plus 5 over 2 is still 5 all over 2. So this is write it at once, 5 all over 2. Alright, so the next thing we are going to do here, we are going to make the left hand side a perfect square. Take note of this. The left hand side a perfect square. How are we going to make the left hand side a perfect square? We are going to have the coefficient of x. That's how to go about that. We multiply the coefficient of x by half. Alright? And then we square the result. What's the coefficient of x? The coefficient of x is minus 3 all over 2. We multiply it by half. And then what we will do? We will square the result, so that this will not be a bit confusing to some persons. 3 over 2x. Alright, I think that's better now. That's better. Alright, so, and minus 3 times 1 is minus 3. 2 times 2, that gives you 4. We square the result. We square the result. Alright, so it doesn't just end in squaring this result, but we're going to add this result to both sides. Let's add it to both sides. This will become x squared minus 3 all over 2 x plus minus 3 all over 4 all square equals to 5 all over 2 plus minus 3 all over 4 all squared. Now, it's important to note that I had the full right to open up this bracket, and this is going to be 9 all over 16. Minus 3 squared will give me 9, 4 squared will give me 16. But it's not always advisable to rush to do that because of what we're going to do in the left-hand side. You can open that bracket, you can expand that in the right-hand side, but it's important you stay with this on the left-hand side. Why is this important? This is very important for when you want to factorize the left-hand side. So adding this to both sides has successfully made the left-hand side a perfect square, and because you made the left-hand side a perfect square, you can easily factorize the left-hand side. Let's see how we're going to factorize the left-hand side now. So we pick this is x squared, but when we put x squared, we're going to say this becomes x. We pick the term inside here. The term inside is minus 3 all over 4. And then we square it. We get over here. And when we get over here, you can see that you can now open up this bracket. So this becomes 5 all over 2. Let's square this. This is like saying plus minus 3 squared gives you 9. 4 squared gives you 16. Question: why did I not consider the middle term? The reason why I didn't consider the middle term in the factorization is because the third term was derived from the middle term. So, in other words, this term is in this term. So when factorizing, I don't need this term. This is what makes the perfect square. So when you're factorizing the perfect square, all right, the first term and the last term as square terms, you just pick it and pick the last one. Remember, don't say plus 3 over 4. No. It's going to be minus 3 all over 4 squared. If you expand this term, you can pause the video and expand this term as you're watching, so that you will agree with me that expanding this term will give you this term. You can do that and you're going to learn more. Alright. So we proceed, and then this is going to be, okay, it's going to be x minus 3 all over 4 squared. If you do this quickly, you would agree with me that doing this quickly is going to give you 49 all over 16. Doing that quickly will give you 49 over 16. Proceeding from there, we are aiming at making x to stand alone. Doing that, take the square root of both sides. Take the square root of both sides. When you take the square root of both sides, this is going to be x minus 3 all over 4 all square. I'll take the square roots, and this is 49 all over 16. I will take the square root. Now, when I do that, remember, we are going to introduce plus or minus. That was explained in the last video. All right. So, moving forward, because of the square root, the square goes off. The square cancels the square root. So this is x minus 3 all over 4 equals to plus or minus 49 over 16. That gives you square root of 49 is 7, and square root of 16 is 4. All right. So moving forward, so x equals to, we are aiming at making x to stand alone. So this becomes plus 3 all over 4 plus or minus 7 all over 4. So this is the solution of the quadratic equation. But to move forward to get the roots, you can see that the first value of x is going to be 3 over 4 plus 3 is the same as 3 over 4. The first solution would be plus 7 all over 4. Yes, 3 plus 7 gives you 10 all over 4. You can see that 2 cancels here, 2 goes here, 5, and 10 over 4 gives you 5 over 2. You can represent 5 over 2 as 2.5 or 2.5 or 2.5. So that's the first root. Alright. So the second root of the equation, alright, let me just continue it on the other parts. The second root, which is x2, would be, we are going to take the minus. So that is 3 all over 4 minus 7 all over 4. So x2 equals to 3 minus 7 would give us minus 4 all over 4. So x2 is simply minus 1. Minus 1. So we can see here, finally, that in this solution, my x1, sorry, I think the first value here is x1. My x1 is given as 2.5, and my x2 is given as minus 1. You can present your answers this other way, that the root of this equation using the method of computing the square is either 2.5 or minus 1. So there are two roots. Quadratic equation doesn't have two roots. Alright, see you in my next video.
Alright, so you can like, you can subscribe, and you can hit the notification bell so that you'll be notified whenever I release new videos. Don't forget, learn with master. Alright, so you can share this on all your social media handles, and see you in my next class.